Hey Jonathan, this is a video to answer your question. I guess my summary of your question was you were under the impression that your house was incredibly energy efficient, and was that true, or did you do this thermal simulation correctly? That's the way I interpreted what you were asking. Um, okay, so if I go to, when we're looking at thermal simulations in Climate Studio, where we see the zones is in the wireframe. So if I come here, I can see that there's some major problems here, and which I'll explain in a minute. You actually don't have any windows, and you don't have a completely enclosed zone or zones. And I can tell that because there are no windows anywhere here in your zones, and also just by looking at this. Um, so I think though I'll try to quickly explain how you would do this. So I built another model um, based on, well, I mean, it's your model. I just cleaned it up and set it up for a thermal simulation. So here's your house, and here are the zones that I made for the house. So you see that they occupy the same space, but let's just think, what are we doing in a thermal analysis? We're saying, okay, I want to pick a volume of air that's inside, so everything inside this poly surface, and I want to compare it. Well, I want to see how it's affected by the changing climate outside. So, in and the, I'm trying not to get too complicated here. We'll cover this in a lot more detail next semester in Architecture 413. That's architectural simulations, and that's a required class, so you have to take it. But anyway, so let me just keep focused here. I now have two poly surfaces that I'm going to make the volumes of air that I'm separating from the outside. I've also got windows now that are just surfaces that are sharing a surface in the thermal zone. So I've got, here's my thermal zone, and here is a window, which is just identifying where are we cutting a hole, or where are we changing the material basically in that thermal zone, and having a window that's transparent to the sun and has various properties. Okay, and then I have a ground. And why do I need a ground? Well, I'm saying that I'm separating this volume of air from the outside. Well, uh, most of the surfaces are going to then be touching or in contact with air, and air has different properties than dirt or ground. And so the part of the building that's touching the ground has to be identified because it's going to have a different heat flow and other properties compared to the parts of the building that are touching air. So that's the three components we need to just, we don't need the chimney right now. We could talk about how to simulate that, but it's really all of that's going to be within the zones we're creating. So if I now just select these two poly surfaces, add them as zones, I'm going to choose the and these are templates, and I think you probably just chose residential. I'm not sure what you did. I'm now going to rename these, and I'm going to go to wireframe. You'll see that there's already windows here, and that's because I did this before and deleted it just when I was building the model before making the video. So I'll talk about the windows in a second, but I'm going to name these zones. I'm going to just call this house, and this green or sunroom, whatever. I don't know if they're supposed to be, but that makes it clear to me. Making the point that I always want to be organized here. If I now edit these two zones, I can come into this template. There's I don't know, 100 settings in here, things that we'll talk about next semester. I'm just mainly going to change this from multifamily to single family home, and I'm just going to call this general. This is just a label, but the single family home is important, and I'll talk about that why in a minute. Okay, so again, lots and lots of this is where we define the building envelope. We're just using a preset, right? So we're not changing anything. And okay, I've got my two zones. I've actually already got the windows. Let me show you how I would have added those. I have them on separate layers here. So I would have come in and selected these objects and come and added them as windows. And we see default glazing is the default. So that's what they're on right now. And those were then added, and you'll see that if you open up these zones that everything is, all the different faces are defined. So for example, I'm going to come back to here, wireframe. Um, so I'm in the house. On this facade, I've got 4 windows. There's the roof. There's a facade without windows. There's an exterior floor. A facade without windows on the other side. So these are all definitions that the simulation needs to have to know how to think, or to calculate how that facade is interacting with whatever it's touching. So for example, let's see, this one, where was the other one? Sorry. So, oh yeah, the portion of this facade that's touching this building is not connected to the outside. So if I go down to this one, the sunroom, let's see. Right, so this facade here, this yellow, you can see that's just actually touching the other building, so there's no air there. So the program needs to know that. Okay, so I've got my windows and so I've got my opaque surface, my opaque zones, my windows, and now I'm going to add the ground. So I'm going to select the ground, which is just this poly surface here, you'll see. I select this. So I've selected that poly surface. I'm going to add it as ground. And now if I come to wireframe, I'll see that I didn't add it. Let's collapse this and this. Do that again. I'm selecting this poly surface. There it did. So now I have a ground boundary here, and the portion of that surface that's touching the ground of the building is the surface that's been identified. Okay, now I'm ready to run my simulation. So let's do it. I'm in New York. I assume you were there also. This DOS window opens up to let us know the simulation's running. This is a small model, so it's very quick. And now we see that I have outputs. Let's compare these to yours. So first of all, what do we have here? Site EUI is the amount of energy, it's the energy use intensity per, in this case, square foot. Carbon, this does not talk about it. It's actually wrong in the IP version of, or the IP conversion. This would be correct, but now we're in metric units, which we don't typically use in the United States, in architecture at least. Okay, so we're talking about the site EUI and the baseline. What's the baseline? That comes from this setting here, where we set single family home. And that's basically saying that there's there are studies have been done, and they've picked a bunch of different types of buildings, and for example, single family homes, and they said, what's the average energy use intensity for a single family home? And that's our baseline. That's what we're, just to be sort of normal, we want to get to this level, or we want to be average. And so let's look at your results. First of all, you had 49 because for your baseline, because you had picked something else for your zones, and I think you picked, right, you picked multifamily housing. So it has a different expectation for how energy efficient it is. We could talk about why. But then you look, you see you have a crazy high site EUI, about what, 12 times or 13 times the baseline. So just looking at the results, I could see something was wrong. Yeah, this makes no sense here. To me, so this is the green is all envelope. It means we have no other loads. So I could tell that there was something wrong here. That's why I investigated and rebuilt it. So now we have this is a sensible, and there's a lot of information here that we could talk about. I'm not going to do it. I am going to change one thing. I'm going to come back to your zones. If everything is open, then I can just come and select everything and edit any component. It's going to take me and say, okay, how do you want to change the zone? I don't want to change the zone. I want to change the windows. So now I'm going to go to Windows. I'm going to change this default glazing to something better. Well, I mean something more energy efficient. Let's just pick this. I don't know. And now I'm going to run the simulation again to see if we get a change. And we do. Pretty substantial change just by adding the windows. You can see that our well, I won't even get into explaining these things. I don't know how much you guys have got into that in environmental systems. But my point is here that then I said single family, default, glazing. I'm just going to put better glazing. That's really lame because I need to know more exactly what's going on. But the point is now I have a little map of what I did, and I can come in and understand why things got better and continue to iterate and improve this. So the summary is your design could be very, very energy efficient. The way you had modeled it, we didn't know because it was just broken. But I've already quickly modeled something that's at least well below the baseline by applying templates that we could talk about in more detail why they were energy efficient. All right, that's my attempt to answer your question. It was good to see you again, and yeah, keep in touch. All right.